Here we have the inside of the IBM power supply, which is around a 1300 watt power supply, I'm guessing. It doesn't really say, it does give you the power rating on the side. I'll put it in the description how many watts this thing is. This is, I believe, what you call the filter board, so your AC comes in through here. You've got, where's the bridge rectifier? Always filtering down here. Oh, and then rectifier down there, I believe. I can't see another one. There's an MOV, I believe, here. There's a relay at the end there, big old resistor, an inductor, some transistors there by the looks of it, and these massive, absolutely massive caps. Two massive 400 volt, 560 microfarad, 450 volt, 560 microfarad capacitors. Nippon Chemicon. There's a Rubicon 180 microfarad, 400 volt, 105 degree rated cap. This side of it's more to do with the actual transformer and the switch mode part of it itself. So got a bunch of transistors in there, I believe. Small transformer on here. Your main transformer here. More inductors. More capacitors, more filter capacitors there, Electrolytics, all Rubicon, and Nippon Chemicon. More transistors down here, MOSFETs rather. Some DC to DC converters here by the looks of it, and logic for the control of this beast. Got a thermistor there to check the temperature of it, so if it gets too hot it will shut down. Although I don't think it's going to get that hot with this massive Nidec Ultra Flow fan. Thing's absolutely insane. They weren't worried about noise with this thing, they're just worried about reliability. These kinds of servers are meant for like life critical applications where if it goes wrong, or rather the cost of it going wrong is higher than the cost of it going wrong makes the cost of the unit seem insignificant, basically. So the cost of downtime and the fact it could pose risk to life, like in hospitals and things like that, or scientific research, things like that sort of thing, where if it goes wrong it's absolute disaster and it's going to cost millions or even billions or even endanger life. So that's why they have two of these. On some servers they have 4 power supplies. This one has 2. They're really heavily built, so if one dies, you've got another one. You go hot swap it out for a new one ASAP. You wouldn't just leave it running on one power supply. You'd swap the other power supply out immediately, and there'd be like an alarm or at least a flashing indicating light to let you know there's a problem, as well as an error message thrown up on the network telling you what software you're running to monitor faults and things like that. Though these are massively built. I think it did say, there we go, 118 amps on the 12 volt rail. Damn. We're at 240 volts for the way, so that's the bit you want to be looking at. It's the model DPS-1520A. Doesn't tell you the out. It does say output, but it's in Chinese. .240 volt, 8 amps. Yes, it's pretty significant. That's the input power. That concludes the video on this little, well, rather big power supply. I will put it back together, and I will put it back in the server and do something to the server. Can I just say, actually, a word of caution? If you plan on taking anything like this apart, watch the capacitors. This hasn't been powered on for a long time. I'll plug the other one in, not this one, and therefore these capacitors shouldn't have any charge in them. If you go on removing this board or touching things in here, or touching down in here, and therefore got a full charge, say 240 volts, and you get a zap off of it, that ain't going to be fun. In fact, it could even be fatal. So don't go messing around with this stuff unless you know what you're doing, or at least have an inkling of knowing what you're doing. Right, that concludes this video. I'll see you later.